Hi, in this video we're going to try to solve this problem. We want to show that if the flow F is defined in a rectangle R and has zero divergence at every point of R, then the rate of flow across every closed path in R is zero. So given a vector field F defined as Fxy, Gxy, and we know that the rate of flow across a closed curve is going to be of this vector field is going to be the vector product of f and the unit normal vector n ds, which is equal to f xy times no, f is negative gxy dx plus fxy dy. Now we have this. We can draw here that we have a curve C, and we take this small del ds, and the normal vector unit is going to be n, and the flow f. So we have here that the tangent vector at this point is going to be dx over ds dy over ds. This is the unit tangent vector. So that means that the unit normal vector is going to be negative, no, dy ds over ds and dx, negative dx over ds. If you have the product vector of these, you're going to have 0. That means this n is perpendicular to the tangent vector. So here, if we want to prove this, like from here, so this is going to be the integral, the line integral, like f xy gxy and dy, this is n, dy over ds, negative dx over ds. This is going to cancel, and we're going to have f xy dy minus g xy dx. So that's what we have at the end, as a result that the rate flow is f is negative gxy dx plus f xy dy. By hypothesis, we have the vector field F defined in a rectangle R has the divergence 0. What does that mean? Is the divergence of F is defined as df dx xy plus dg dy xy. And we have this equal to 0, which means that df over dx is equal to negative dg dy. So now let's take a curve C that's closed in R, and let's S be the region bounded by C, and we take C oriented counterclockwise. So now we can apply the Green's theorem. The Green's theorem says Green's theorem. So if we have a vector field PQ, for example, so we know that the line integral on a closed curve of P dx plus Q dx is going to be the double integral on the region bounded by the curve S dq dy minus dp dx dx dy. This is the Green's theorem. We're going to apply the Green's theorem to what vector field? Our vector field that we're going to apply it to is negative gxy fxy. So we're going to take p equals negative gx y and q equals fx y, and we're gonna have that this negative gx y dx plus fxy dx is gonna be equal to the double integral of the region over the region S. That's d, have here q, that ds df dxy over dx minus the p, so it's gonna be now negative dg dy dx dy. So here we put the result. So this is gonna be equal to the double integral of s over s of df over dx xy plus, because we have minus negative, so we're going to plus dg dy xy dx dx dy. xy dx dy. And we know that we have the this is the divergence here, and we know it's equal to 0, but it means that this is equal to 0. So we proved that the rate here is going to be equal to 0. So that the rate of flow across every closed path in R is 0. Thank you for watching this video. Make sure to like and subscribe.